Hello, everyone. All right, so we are going to be continuing to look at atoms, elements, all that kind of stuff. And so today what we're going to do is focus on substances and compounds. I'm going to see what we get through. I want to make sure that the lessons aren't getting too long for you. I'm hoping to kind of get through some of the periodic table of the elements as well, but we shall see. Okay, so let's take a look here. So we are having it where you should be on this page of your notes. Please keep in mind that you need to have it where my best piece of advice to you is have it where if you are ever trying to find a document, this is what I suggest. Have it where you open up a new document, or sorry, a new page on your Google Chrome. If you don't have Google automatically showing up as your first thing there, then what you can do is just do google.ca and then simply have it where you go to this. And then what I actually would suggest you do is instead of going into Docs, go into Drive. The reason why is because sometimes you have, like, let's say Shakespeare, for instance. This is obviously social studies, but still, these are all the ones that came in. So you can see that here, this was actually Google Slides. And so because it's Google Slides, if you're going into Google Docs and trying to do a search for it, you're not going to find it. So obviously for this one, we're talking about science. This one is actually going to be in your Google Docs, but just a heads up that if you're needing to find it and you can't find it anywhere, go into your Google Drive and then do a search for it, and then you should be able to have it come up, no problem like that. Okay, going back to what I was saying. So we are starting here with pure substances versus mixtures. So I'm just going to move this out of the way here. Now we're going to take a look here. Now with it says here that there are only two classes of pure substances. So that would be elements and compounds. Now we're going to take a look at the difference between those two. And honestly, I know you guys have probably gotten stuff like this earlier in science classes before. So this should be more of a review for you. If not, hey, that's okay. Pay attention and hopefully you're on the same page by the end of this. So an element, keep in mind, that's going to consist of atoms that are all the same. So just think of it that way. Element, everything's the same. It's the same type of material or same type of molecule throughout the entire element. Whereas with a compound, you have two or more kinds of atoms in a fixed ratio. So think of H2O, think of water. You would have your two hydrogen and one oxygen. And so they would be in combination like this. So it's a compound. So a compound, just think of it this way. You have two or more kinds of atoms. So different, they're not all the same. So two or more different kinds of elements. So think of it this way, like two different elements coming together basically, and having it where they're in a fixed ratio just like this. So let's keep digging into that one here. So here on the left side, this represents an element because everything is the same, all right? There's nothing different. They're all these nice little beautiful purple dots, the same size, everything like that. It is all just an element. So it's made up of atoms of only one kind. Now on this side here, we have it where it's representing a compound. So that simply means that, of course, we have it where the compound consists of atoms, but there's more than one kind. And the thing is, though, is that keep in mind that they are combined in little clusters, and those clusters are all exactly the same. So you do not see any differences. So in a compound, yes, you have more than one type of atom in there, but there's still uniformity in the sense of the fact that you're going to see each mixture, or sorry, each combination is going to be exactly the same, exactly the same, exactly the same. There's not going to be anything different popping up within a compound. It's going to be just those certain elements mixed together in fixed ratios. They're groups basically, and each group will look exactly the same. Let me know if any of that's not making sense. Sometimes I'm not too sure how much time to spend on certain things and how much you're just like, okay, got it, move on. So if you're not understanding something, just let me know, please and thank you. But also just one thing to keep in mind is that with a compound, that they have at least two different kinds of elements or different kinds of atoms that are mixed together, and they're chemically bonded to each other. So they are chemically bonded. Just again, think of hydrogen and oxygen. When they're chemically bonded to each other in a compound, you end up having water. Okay, and so it's now chemically bonded to each other. So here we're looking at a couple different things here. So you see that we have copper on this side, and it is an element on the periodic table of elements, and that has only copper atoms throughout it. Same with silver. Silver is something as well that is on the periodic table of elements, and it only has silver atoms throughout the entire thing there. And so with molecules, that's two or more atoms that have chemically bonded with each other. The atoms in a molecule, so think of it this way, atoms are the itty bitty tiny parts, and then we've got atoms forming within a molecule. So atoms in a molecule can be of the same kind, in which case it would be a molecule of an element. So just think of how we looked at the copper and the silver. So we have all of these atoms within here, and they're all the same though. They're all the same. There's no differences between the atoms within that element there. So they can be of the same kind, in which case it would be a molecule of an element, though there are some special cases of that, but then they can also be of different kinds, and so that'd be the compound, keeping in mind things like H2O and stuff like that. So molecules can be elements and molecules can be compounds. Think about that. And it comes down to the atoms that are composing it. So the atoms can be either all exactly the same, which means it's an element, or they can be all different, which means it is a compound, or not all different. You know what I mean? They're in groupings, but there's at least two different kinds. Okay, now here we're going to take a look at this a little bit more later on when it comes to things to do with diatomic and triatomic molecules, but I'm going to just quickly go over it right now. It has it where diatomic means that you have a molecule made of two of the same atoms bonded together as an oxygen, so like O2. So Di, that means two. Triatomic, if you're paying attention here, triatomic simply means tri is three. All right, so that means you end up having a molecule made up of three of the same atoms bonded together, like ozone, which would be O3. So you see here, the O3 here, they're all chemically bonded to each other, but they're all the exact same atom. All right, so they're all the same atoms, but they're chemically bonded to each other, and there's three of them, so it's a triatomic. Whereas here we see that like H2, N2, O2, F2, and so on, we see that these, we only have two that are chemically bonded to each other. So that means it's a diatomic molecule. All right, hopefully again, that makes sense. You can feel free to let me know if it doesn't. All right, moving on to the next page here. We have it where it's talking about if it's an atom or a molecule. And so taking a look here, now this one here, we only have just one thing here, that's an atom. Now what happens is this is a molecule, it's a diatomic molecule. Remember how that's going to be two of the exact same atom that is chemically bonded to each other. So this is a molecule, a diatomic molecule, because they're all the same. That's all the atoms that are within this are the same. So it's a diatomic molecule. Now here, and that's like, we're talking about an element here. Now here, we actually see, we obviously have different atoms. We have one here, the nice blue one here, and then we have three white ones. So here, we actually have four atoms all together, and it is a compound because we have two or more different kinds of atoms within this chemical bond. Now here we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 atoms all together. It is a compound. We have 3 different types of atoms all together that are coming together in a chemical bond. So molecule, 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 just an atom. So an atom, smallest unit, and then molecules are going to be composed of at least 2 atoms, basically. All right, and if they're all the same, it's an element. If you have 2 or more of different kinds of atoms, you've got a compound. And we're just going to quickly go over here now, and we're going to go to the Google Doc in just a moment. So compounds, there are at least 118 elements in our known universe. Again, keeping in mind, we're going to look at the periodic table of elements soon. They can form compounds by bonding in millions of different combinations. Like, just amazing when I look at this as far as how creative God is. It's just, I love how, like, it just it knows no bounds as far as his imagination, his creativity, and how like there's just so many different combinations that you can make just within the different elements that he has in our universe that we know of. And so we obviously know about water, and that's one of the most important compounds that we need to be able to survive. And so with that being the case, obviously we know it's one oxygen atom and two hydrogen atoms. And then what would happen is they would look a little bit along the lines of these, almost like those Mickey Mouse drawings where you've got the we've got the bigger oxygen molecule here, and we have two smaller hydrogen molecules, atoms, sorry, that are chemically bonded to it. And each element has its own unique chemical formula. We can combine these symbols into a chemical formula for water. And we see here now, just keeping in mind, when you've got two of an item, what they do is that you see this little tiny two here. That's generally what they do, is if they have like a diatomic molecule, which hydrogen is within the chemical formula for water, then they put that little two there, and that shows that they have two of those atoms. All right, but you only have one oxygen. Because if you ended up putting a two in front of the entire formula, then what would happen is that would mean that you would have two hydrogen and two oxygen, or two oxygen. So keeping in mind that this little two refers to just the hydrogen, and it shows that you have two of those atoms, and then because there's no number two directly after the oxygen, that means you only have one. So then if you're taking a look here, if you're looking at carbon dioxide, you see that with carbon dioxide, you have one carbon, and you have, oopsies, you have two oxygen. All right, so two oxygen atoms and one carbon atom that have bonded together to create carbon dioxide, and that's what we breathe out all the time. And I'm just going to quickly show you a couple last pages, then we're going to go to our Google Doc here. So all water molecules are exactly the same, so there's no differences. Like, that's the neatest thing, is that there's so many different combinations that we can come up with, but at the same time, God made it so that there's still organization, there's still uniformity within all these different varieties that are out there. There's still order. And so he has it where with all these different combinations that can come up with, when you have a certain combination, such as water, H2O, every single compound for water is going to look exactly the same as far as it's two hydrogen atoms and one oxygen atom. And so they're held together by a chemical bond in a fixed ratio. Now, you technically, theoretically, would be able to, if you had enough energy, to break those bonds. And I'm not talking about you jumping up and down or going on a trampoline or whatever, but like you'd have to use, in a laboratory, being able to use enough energy to break those bonds. Then what would happen is it would separate. So let's say if you had two identical H2O compounds, if you had enough energy to separate that, then what would happen is automatically it would end up having it where immediately the hydrogen, you have two sets of hydrogen, they would end up having it where they go into pairs of two. And then for the oxygen, there's two of them all together, those would go into pairs of two. So they kind of pair themselves off if you were able to separate them through using enough energy. All right, thank you for hanging in with me there. Let's just quickly fill in this part, and then I'm going to end this video, and we'll have it where I will take a look at the periodic table of the elements in the next one. So elements cannot be broken down into other pure substances. So they're like, basically for an element, let's say you have copper, you have gold, you have silver, hydrogen, oxygen, doesn't matter what the element is, it can't be broken down any further. It is just that particular element. So silver is silver, no matter how you might try to break it down, like you can't. It's always going to be silver. Now, elements are made up of only atoms of one type. So again, keep in mind, if you've got a oxygen atom, it's only going to be oxygen atoms within that element. You're not going to have any other type of element showing up in that. Otherwise, that automatically becomes a compound. Only 118 elements today that we know of. And the properties of each element is different from properties of all other elements. Again, it's the neatest thing is that where God had it, where he formed all these different kinds of elements, but then made it so that they are all unique, that they have, or even if they have similarities to other elements, it doesn't matter. They still have their own unique qualities that make it so that they are still their own thing. So silver is still silver, copper is still copper, hydrogen is still hydrogen. It doesn't matter where you look or where you test for it. What happens is that they're all going to be their own set thing, but different from each other. And so it doesn't matter where you look in the world, where you test for silver, whatever it might be, like it's still going to have it where silver is going to be different than gold and so on. So I know that seems extremely self-explanatory, and I'm probably taking way too long on this one here. So again, thank you for bearing with me on this one. But just think of it this way. Atoms, they're like the letters in the alphabet. They're the building blocks. Just like that video was saying, how you have like the letters form the basis of the English language and being able to communicate, being able to read and write and all that kind of stuff. And so with that being the case, atoms are the same idea, that they are the building blocks. They're like the letters of the alphabet. They form the basis of everything. Everything that exists right now is formed from atoms. Last little bit here, let's take a look at, we have compounds, and compounds can be broken down. Just like I was saying, if you had enough energy, you could technically break it down. So it can be broken down into elements because they are whole number ratios of elements. So that simply means, like I showed you with the water compound, that if you use enough energy, let's say you had 2 water molecules, then you end up having it where they would split off into pairs automatically. So you'd have your hydrogen bonding together, and then the oxygen molecules bonding together. All right, they are not mixtures, so they have new properties, which are totally different from the elements they are made of. So again, think of water. You have H2O. So yes, we breathe in oxygen, and actually we technically breathe in some hydrogen as well. But as soon as you have it where you combine them, now you end up having a completely different state of matter. You actually have liquid. You have water. You have H2O. So they're not mixtures. It's a chemical bond. So if you had, like, say, some hot tea and you added a little bit of sugar or honey to it, so that's a mixture. It's a mixture, but it's not chemically bonded to each other. Whereas here, when it comes to 2 different atoms, different kinds of atoms that are combining together, it's a chemical bond. And so it requires a lot of energy to be able to separate these compounds. And they also have new properties compared to the elements that they were made from. When 2 atoms combine together, they form molecules. I'm trying to look at my notes here while I'm doing this. Just like I showed with that one picture, just 1 atom on its own, it's an atom. As soon as you have at least 2 atoms together, it now is called a molecule. All right, and so compounds are like words made up of elements. Think of it that way. Hopefully that helps a little bit. Thanks for hanging with me on this. If there's something that's not making sense, please let me know. That way I can address that as soon as possible.